formation, but we can probably finish this next time. So there is this disk of stuff that's left over, and it's going to start coagulating into bits and pieces, and they'll start piling up, and that's how planets are made. Again, this is not a fantasy. Here is a picture of actual first detected protoplanetary disk around star Beta Pictoris. The star itself is blotted out here with coronagraph, and many more like that have been seen. So we've seen these actual cold disks left over from star formation, inside of which planets form. And the formation goes through several steps. First, you have dust grains. They can stick together to more or less chemical forces, and eventually they have enough mass, so gravity becomes important. So when they stick together, dissipate some energy, they can stay together, and you start accumulating ever larger pieces from dust to little pebbles, through planetesimals, which are like comets or asteroids, through whole-sized planets. So this process is understood why that happens, although the details, of course, is something that we still study through exosolar planetary systems. Now, the important concept here is why that you have different composition of planets depending on how close they are to their sun. If they're closer to the sun, the heat, radiation will tend to evaporate and push out all the volatiles. And so you'd end up with the rocky planets. But beyond certain line, where things no longer evaporate, so it's called frost line or snow line, you're going to keep the volatile things, and they can also be part of the planets. So indeed, this is what we see. We see inner planets in the solar system are rocky planets, and then in the outer solar system are gas giants. And the leftover pieces from this whole thing are in comets, and they're out there in the Oort cloud. So the planet and star formation finishes with combination of things. First, the radiation pressure. Solar wind pushes particles out, right? And then planets themselves go around and sweep the stuff because now they have enough gravity to accrete material from around their protoplanetary vicinity. And that means in the early stages of planet formation, a lot of asteroids fall down, and you all computed what happens. So this is why planets have molten cores. There's a great deal of kinetic and binding energy that accumulates that melts those rocks. And then sometimes you can toss it out. So the important concept to remember here, and this will come very handy next time, is this concept of a frost or snow line that kind of divides planetary systems, inner portions where you only end up with heavier stuff and rocky planets, outer portions where you get gaseous planets like Jupiter, Saturn, fluffy, methane, ammonia, that kind of thing. And amazingly enough, for Sun, this is about 3 astronomical units right between Mars and Jupiter, just where it should be, right? So with that, let's finish for today.